Welcome back to Math Journey. Today, we've got a geometry puzzle that's simple to understand but tricky to solve. Check this out. We have a right triangle with a semicircle perfectly fitted inside. The triangle's side length here is 3. And over here, we have a length of 1. Our challenge is to figure out the exact area of this shaded region between the triangle and the semicircle. Sounds straightforward, right? Think you can crack it? Grab a pen, stay tuned, and let's dive into this mind-bending problem together. Now, before we dive into solving this, take a moment to think about it. What jumps out at you? Can you spot any connections or familiar ideas? Even complex problems often have a simple starting point. Give yourself a few seconds to explore the possibilities, and then we'll solve it together. Alright, let's break it down step by step. Since this triangle is right-angled, we can use some interesting properties here. First up, notice that the semicircle is tangent to line AC at point D, which means the radius of the semicircle is perpendicular to line AC at point D. This perpendicularity will help us use some clever geometry. Now, if we set the radius of the semicircle as r, we know that the distances of OD, OE, and OB are all equal to r. By using the Pythagorean theorem in triangle ODC, we get the equation r plus 1 squared equals r squared plus x squared. After expanding this, we have r squared plus 2 times r plus 1 equals r squared plus x squared. By simplifying, we find that x squared equals 2 times r plus 1. Let's call that equation 1. Now, here's where it gets fun. We can see that triangles of ABC and ODC are similar, because they are both right-angled and share angle of ACB. So, we can set up a proportion here. According to the properties of similar triangles, we have AC divided by OC equals AB divided by OD. Or in other words, 3 plus x divided by r plus 1 equals 3 divided by r. Solving this proportion will give that r equals 3 divided by x. Let's call this equation 2. Alright, now we have two equations. X squared equals 2 times r plus 1 and r equals 3 divided by x. Time to substitute. When we plug in r equals 3 divided by x into the first equation, we get x squared equals 6 divided by x plus 1. After simplifying, turns into a cubic equation. X cubed minus x minus 6 equals 0. Now, this is where a bit of guessing and checking comes in handy, and we find that x equals 2 satisfies this equation. But we're not done yet. Since the equation can be factored, we need to make sure we've considered all possible roots. We'll factor the cubic equation as x minus 2 times x squared plus 2x plus 3 equals 0. This means that either x minus 2 equals 0 or x squared plus 2x plus 3 equals 0. Solving the first equation, we get x equals 2. Now, let's look at the second factor, x squared plus 2x plus 3 equals 0. We'll check if it has any real roots by calculating the discriminant. The discriminant for this equation is b squared minus 4 times a times c, which equals 4 minus 12. That gives minus 8. Since the discriminant is negative, there are no real solutions for this factor. So, the only real solution for our equation is x equals 2. Now, with x equals 2, we can use our second equation, which is r equals 3 divided by x, to find that r equals 3 halves. Great, we've got everything we need to calculate the areas. Let's start with the area of triangle ABC. Since the base BC equals 2 times 3 halves plus 1, which simplifies to 4, we have the area of triangle ABC as 1/2 times 4 times 3, which equals 6. For the semicircle, the area is half of a full circle with radius r equals 3 halves. So the area of the semicircle is 1/2 pi times 3 halves squared, which simplifies to 9/8 pi. Finally, to find the shaded area, we subtract the semicircle's area from the triangle's area. The shaded area equals 6 minus 9/8 pi. That's our solution. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.